All right, now let's really start getting into it a little bit here. The unit circle. This is going to drive all of our trig. If you can get this unit circle basics down, pretty much your best day ever. All right, so here's some things that we need to talk about. If I have the sine of theta here, that on the unit circle here, so here is my unit circle. Yeah, let's try again. Oh my gosh, it's getting worse. Not awesome, but I think we're going to go with it. If I'm looking at my unit circle, sine is going to be the y values. Cosine will be your x values, all right? So whatever theta is, if I'm looking at this point right here, and this is theta, and I have my x, y coordinate on this circle, your x value here is going to be indicative of the cosine of that angle measurement. Your y value is the sine of that angle measurement, all right? So if I have sine and cosine, so this is the other thing, that sine, is S-I-N-E, right? It is a function. The function sine here is my inside input value of theta. Like what we talked about with our natural log. The natural log is my function, and then that inside input was that inside part. You can't break those up. The same thing that's happening here, but my inside value is going to be an angle measurement. Same thing with cosine. C-O-S-I-N-E. That is an actual function that I'm talking about, all right? Tangent is going to be y over x. So in order to get tangent, I have that sine over cosine. Tangent is y over x. Now, we can also have cotangent. That's going to be x over y. We can also have secant. That's going to be 1 over x. And cosecant, CSC, will be 1 over y. All right, there are 6 trig functions, and here they are. Oh. Here's what I really want to point out to you. Look at what's going down right now. Sine is equivalent to y, cosine is equivalent to x. Everything else deals with x and y. They all relate back to sine and cosine. All right? That is the kicker. That's what I really want to bring home, if you will. So right now, I'm just going to load you up is what's going on. Here's a bunch of different identities and things that you have to know. You have to memorize these. All right? You need to know that the tangent of theta is equal to sine theta over the cosine of theta. Well, no duh. If sine is y and cosine is x and tangent is y over x, that also means that it's sine over cosine. That's called quotient identities. I can also have cotangent of theta is equal to cosine over sine. Quotient, that's an I, identities. All right? Okay. The other thing that we can look at are reciprocal identities. Same thing that's happening right here. If I have tangent, cotangent, those are reciprocals, y over x, x over y, right? Reciprocal is that flip. Sine goes with cosecant, cosine goes with secant. So let's write these out. Let's change our color so that it doesn't look like it all blends together. Reciprocal identities. So if I have, now if one is a reciprocal of another, then it goes back and forth, right? So if I have the sine of theta, sine goes with cosecant, which in turn means that cosecant goes with sine. Either way, they are reciprocals of each other. Do you see what I'm getting at here? So sine and cosecant are buddies. Also, friends. We have cosine of theta is 1 over secant, meaning that secant is 1 over cosine. All right? And then lastly, what we already know is that tangent is 1 over cotangent, and cotangent is 1 over tangent. Now, you got to know these, right? We are in a unique situation that we are not face-to-face right now. So this is being a recording. We are not face-to-face, and because we are making this virtual class that we have going on, I can't monitor if you are looking at your notes, but I am here to tell you right now, you have to know these. You can't rely on your notes. You can't rely on looking this up. So now this is your chance to be an adult, right? An adult learner is what's going on right now. So know that is a fact. You have to have these things memorized. In order for you to be successful moving forward, in your next classes, you are going to have the expectation that you know this reciprocal identities, these quotient identities, and I'm going to load you up with a whole lot more. You guys know me. I'm going to tell you exactly the ones you need to know, and the ones that are like, nah, that's cool, go ahead and look that up, right? Like in 9.1, I'm like, y'all don't need to know these formulas for linear speed, angular speed, and arc length. I'm going to give those to you because I'm not going to give you something that you're not going to need to be able to recall immediately. You'll have an opportunity to look those things up. This, you need to know it, and we're going to use it a lot. So you have to know all, oops, I hit the wrong thing. You have to know all of these, all right? Okay, and that's going to be on you. So come up with flashcards, do whatever you got to do, but these are common. All of this is very common. It should be like breathing, knowing these. So whatever it takes to do that, that's what you need to do. And we're going to practice these because I'm going to expect that you know them, and we'll move forward. Okay, good. Now here's some more Pythagorean identities. These are the last ones in this little bit that we're going to go through. Pythagorean identities. All right. Here's our first one. Sine squared plus cosine squared is equal to 1 because it's a unit circle. I'm going to suck this down here a little bit. See this circle? So my circle, x squared plus y squared equals 1 because my unit here, my radius is 1. So when I'm talking about this, my unit is a 1. So on my unit circle, then I have my x squared plus y squared equals 1. That's where that comes up with. All right. Also, if we manipulate these and work these around, you can also come up with 1 plus tangent squared of theta is equal to secant squared of theta. All right. And our third and final, 1 plus cotangent squared of theta is equal to cosecant squared of theta. Now I will tell you, as you get into Calc 1 and as you get in past all of that, there is going to be a nice strong relationship between tangent and secant, cotangent and cosecant. So these Pythagorean identities are going to be helpful. The more you can build these trig foundation, the better off you will be. I'm here to tell you, going through trig, the hardest part of trig is just making sure that you have this memorization stuff down. Getting these basic components here memorized That is going to be super helpful for you. Then you can start applying your trig and working through. These are just the basic relationships between them, and that's going to make a huge impact. All right? Okay. Now, when I have my unit circle, putting all of this data and all of these facts down here on my unit circle, then we can find what different angle measurements are. For instance, oopsie daisy, here if I have example 1, I want to determine the values for every trig function. For all 6 trig, I'm missing my E in that too, UE, trig functions. Okay, my first one is going to be 0. All right, this is in terms of radians, which we saw at a 9.1. If I have 0 here, on my unit circle, right here, this is angle 0. Right there is 0. So if this is a unit circle, I am at the point 1, 0. At 0 degrees and 0 radians end up being the same. Oh, and this, I put a degree mark there, but it's not. This problem is in terms of radians. Oh, cool. I'm glad we're working in terms of radians. Okay. So at 0, now here's some things you need to know. What does your x represent? Which trig function? Cosine. What does the y represent? Sine. Okay. So if I want to write all of these out, sine of 0, cosine of 0. Oops, I did theta. Tangent of 0, because this is the angle measure we're talking about. Then I like to come over to the right of that. If I know my sine, then you know what cosecant is, right? Because it's the reciprocal. And this is where we're going to use those. Secant is the reciprocal. Cotangent is the reciprocal. So sine here that I'm looking at, sine is going to be the sine of 0 is 0. Nailed it. Cosine of 0 is 1. All right. Tangent. Now, tangent is sine over cosine. So tangent is 0 over 1. Well, 0 divided by a number is legit. That's going to be 0. Cosecant. Cosecant is going to be 1 over 0. Can I have 1 over 0? I'm going to scoot this little feller over. No, this is undefined. What about secant? 1 over 1. That's still 1. What about cotangent now? Will be 1 over 0. Do you see the issue again? Yep, that one is also undefined. And we will see, because we're getting ready to graph these, that's where we can find some asymptotes. But for now, let's just work these out. All right? Let's look at pi. What if pi is the angle measure that we're going for? So if I have my grid again, I know pi is over here at 180. So if I have this angle that we're talking about here in my unit circle, a unit circle, so this would be the coordinate point, -1, 0. So again, cosine is the x value, sine is the y value. So let's lay all of these out. Sine theta, cosine theta. Oh, no, we know theta. That's a pi. And then I have cosecant of pi, secant of pi, because those are reciprocals, cotangent of pi, the reciprocal. So sine is my y value. What's the y value here? 0. 0. What is cosine? That's my x value of -1. Tangent, sine over cosine. So 0 over -1 will give me 0. Good. What about cosecant? 1 over 0 again is undefined. You guys are getting this. I like it. Secant is 1 over -1, giving me the -1. Cotangent, yep, so -1 over 0, gonna stick with the undefined. Good. Okay, let's do another one. I'm gonna go here with, I'm gonna skip C, just go straight to D. Negative pi over 2. Negative pi over 2. If this is my unit circle, one more try. Oh my goodness, I made it worse. I can't go with that. Not awesome, but we'll go with it. Unit circle, what happens when you have a negative angle measurement? What did we determine is going down there? You're going in the clockwise direction. So if I go down pi over 2, now what did we say pi over 2 was? Pi over 2 is equivalent to 90 degrees, right? If you were to figure that out, pi over 2 is equivalent to 90 degrees. That means I'm coming down this direction to be negative pi over 2. Again with the unit circle, so this coordinate point right here is going to be 0, -1. Now would be a good time for you to pause the video and then come up with these 6 trig functions by yourself. That's the beauty of having virtual in this instance, because now you can pause, practice it yourself, then start it back up. Okay, pause it, practice, and I'm going to keep going. So I have here sine of negative pi over 2, the cosine of negative pi over 2, the tangent of negative pi over 2, the cosecant of negative pi over 2, secant of negative pi over 2, and cotangent. Okay, sine is the y values. In this instance, we have a -1. Cosine are the x values, so we have a 0. Now, tangent is -1 over 0. As soon as I have that 0 in the denominator, that's what's going to give me undefined. Good. Cosecant is now 1 over -1, giving me that -1. Secant is going to be 1 over 0, and that one's undefined. Good. And then that's a negative pi over 2. Here I have 0 over -1, so I have the value of 0. So you're just looking at those relationships, those reciprocal identities and those relationships that we're building up between all of your trig functions. Everything